All right, we are on lesson 10, how are living things molecules form? So remember, you're going to be watching this video to the last second. I will come around at the end of class to make sure you took notes during the video. So that means you need notes. So this sheet right here, 2 sides, glue them in your notebook, add them to the table of contents. What have we been working on? Well, a lot, but most recently we've been looking at Lewis dot structures. We've looked at different models for ionic and covalent compounds and how they bond. And we looked at how this related to where some of the elements are located on the periodic table. And way back in lesson 2, we looked at different macromolecules. Remember how you looked for elements and you looked at charges and we looked at how those elements were related to each other. If you want to review this information, go back to the lesson 2 folder. There's a lot of stuff in there. So this is, for example, the macromolecule information. This is the table that we filled out. Okay, there's a lot of information in there. If you're still confused, I recommend take a revisit. So do you remember, right, that the elements that make up those compounds were carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, or CHONPS with an N. Where are those elements on the periodic table? Well, right there, right? So knowing that, what type of compounds are formed by these macromolecules? Well, if you notice, they're all non-metals, right? So that means these compounds must be covalently bonded, or they must be molecular compounds. So how could we go about checking that? Well, first of all, the macromolecules are huge, right? They're super big molecules. So we could probably look at little sections of the molecules and we could see how those elements bond in smaller sections, which means we could then apply it to the bigger molecule as a whole. Now, remember those notes I mentioned? Now's the time that you need them. So we're going to look at each of those elements in the macromolecules in small pieces, and we're going to record the patterns that we see. All right, so we're going to look at carbon first and then be recording some key information that we see. So I can see carbon in each of these little sections. So for example, here is a carbon, and I can see that that carbon is attached to an oxygen, to something over here, and 2 hydrogens. So that's 4 things. All right, this carbon is attached by 2 bonds to this oxygen, to this oxygen here, and then there is something over here, same within this structure here. In this one, the black atoms are carbon, so I can see here 1, 2, 3, 4. Here I see a carbon, 1, 2, 3, 4. Here I see a carbon, 1, 2, 3, and I can't see it around the other side. There is where there's a double bond, 4. So something that we notice is that there's 4 bonds. What are some other things that hopefully you notice as you look at these molecules? Carbon tends to kind of be in the middle, like there's a bunch of stuff around it, right? And we saw that it could have single bonds, 1 line, and double bonds, 2 lines. And we see carbon has long chains, like look at this, right? Long chain, but then it could also, like over here, be in rings. All right, let's look at hydrogen next. Okay, so hydrogen is in all of these molecules. So we have hydrogen, hydrogen, these white ones, hydrogen, okay, and the white ones again. So what do we notice for this? Well, hydrogen is just like 1 bond, like it's bonded to one thing and then nothing else is attached to it. Because this CH2 here, just because that can be a little confusing, means there's a C with an H and an H. That's really what it means, okay? But you can see that a little bit clearer here when we have this chain of carbons. And on either side, we have hydrogens. So I only see single bonds. They only make one. And they're all like on the outsides of the molecules, like stuck on the outsides. Oxygen next, okay? What do we notice about oxygen? Well, let's look at this one, for example. It has 2 bonds. This one over here also has 2 bonds. This red one, that's oxygen, 2 bonds. This one, look, 2 bonds. Okay, so what do we notice? Well, it's got 2 bonds. And I notice that it does make single and double bonds, right? So I see those here. Okay, nitrogen is next. What do we notice about nitrogen? Okay, so let's have a look. I can see that here nitrogen has 1, 2, 3, right? Over here, 1, 2, 3. Over here, 1, 2, 3. But here, nitrogen has 4. That's unusual. It's different than the other ones, right? So nitrogen has 3, but sometimes 4, okay? Also, I noticed that carbon can be in chains, right? Like these, but it also can be found in a ring. I see that what I can see in these models, it all has single bonds. And like carbon, it tends to be located in the middle, not stuck on the outside. All right, here's phosphorus. When I look at it, I see 1, 2, 3, 4, 5. Then 1, 2. So that's a double bond. 3, 4, 5. That's different. So it has 5 bonds. Also, it is found in the center. There's a bunch of stuff stuck around it, right? And I do see some single and double bonds. Okay. And we're on to S, the last one, sulfur. Okay, so what do we notice about sulfur? Well, here, 1, 2 bonds. 1, 2 bonds. And here's sulfur, 1, 2. Okay. So I notice that it has 2 bonds and it can have single and double bonds. Okay, based on our observations, let's fill out this table. Okay, which elements did we see that formed 1 bond? Hydrogen, right? Which elements did we see that formed 2 bonds? That was oxygen and sulfur, right? 3 was nitrogen. 4 was carbon, but also we saw it in that one nitrogen, right? And then 5 was phosphorus. Okay. So look for CHONPS in this Lewis dot diagram sheet in your notes. Okay, so let's just refresh about the Lewis dot diagrams, right? We can see the dots represent outer electrons, right? As we go this way across the periodic table, we can see that the number of dots is increasing. It's 1, then it's 2, then it's 3, right? And the most number of dots we see is 8. And what we can also see as we go this way, right? The number of dots is the same in each vertical column, okay? So where is CHONPS? Well, there are those elements, right? Time for a vocabulary word, so fill this out. Vertical columns are called groups, okay? On your periodic table, it literally shows you the word group and gives you the numbers. So this is group 1. This is group 2, okay? In a vertical column, in a group, elements in the same group have the same number of valence electrons. So group 1 has 1 valence electron. Group 2 has 2 valence electrons. And we skip this middle section because those are something called transition metals and they don't follow all the rules. And then over here is group 13, but they have 3. 14, they have 4. Okay, so you can kind of see that pattern now. Horizontal rows are called periods. So remember that's going across like this, right? And what we noticed is the number of valence electrons is increasing going across. So in a period, and it's written right here, and it even wrote the word period sideways to remind you that it means going across like this, okay? What do they have in common? Well, if you look, this lithium says 2-1, beryllium says 2-2, then it's 2-3, then 2-4, 2-5, 2-6, 2-7, 2-8. So elements in the same period have the same number of occupied energy levels. That means their electrons are in the same number of energy levels. So based on the periods, period 1 has 1 energy level. Period 2 has 2 energy levels. Period 3 has 3 energy levels. That says 2-8-1. That's 3 energy levels, okay? So now looking back at our notes, what do we notice? What patterns did we see looking at all of those things that we just observed? Well, I can see that phosphorus and nitrogen are in the same group. I can see that oxygen and sulfur are in the same group. I can see that oxygen and sulfur form the same number of bonds. I can see that the number of valence electrons increases as you move to the right on the periodic table. And I can see that not all elements seem to follow that rule of 8, because I know each bond is 2 electrons, right? So not all of them seem to follow that. So what do we wonder? What do we not have answers to yet, maybe? Well, why can phosphorus form 5 bonds? We didn't see anybody else doing that. Why does hydrogen form 1 bond? Why do some form double bonds? Why does nitrogen sometimes form 3 and sometimes form 4? There's a lot of things to think about there. What do we notice about carbon in particular? So that's first in our CHONPS with an N acronym, right? So carbon can make rings and long chains. Carbon's in the center. It can bond to all of the other pieces of the CHONPS acronym, right? So it's the backbone of many molecules necessary for life. We saw carbon in all of them, right? So it's obviously crucial. So now, how do we apply this to phosphorus? So phosphorus and nitrogen are in the same group, right? But phosphorus forms 5 bonds and nitrogen forms 3, sometimes 4. Write your prediction. Why do you think this is happening? Why do you think phosphorus is bonding differently than nitrogen? Why aren't they bonding the same like oxygen and sulfur did, right? What's different about this that makes it bond differently, okay? Watch this to the last second. I'm going to be coming around. You should have taken notes.